Your video file is lying to you. You think you saved an MP4, but what you actually saved is a container holding a codec. And most people have no idea those are two completely different things. That confusion is exactly why your export looks perfect on your Mac and comes out a pixelated mess on your client's PC, or why your YouTube upload takes forever, or why that old AVI file refuses to play on anything made after 2009. Here's the twist I'll come back to at the end. The format you choose matters way less than understanding why formats exist in the first place. Once you get that, every confusing export menu starts making sense. So let's break this down. Every major video format explained. No jargon without a definition. No fluff. Let's go. Before we get into any specific format, you need one mental model. Just one, and it changes everything. Think of a video file like a shipping box. The container is the box itself. It holds everything together. The video, the audio, the subtitles, the metadata. It's the wrapper. The codec, short for coder-decoder, is what's inside. It's the method used to compress and decompress the actual video data so it doesn't take up 400 gigabytes per minute. Same box, different contents. Same codec, different box. They're independent, and they interact in ways that determine quality, file size, compatibility, and export speed. Keep that box analogy in your head. We'll come back to it every single segment. MP4 is the plain white shipping box. You've seen it everywhere. That's the point. Officially called MPEG-4 Part 14, MP4 was standardized by the Moving Picture Experts Group in 2001. Over 20 years later, it's still the default export format for almost every camera, phone, editing app, and streaming platform on the planet. YouTube, Instagram, Netflix, they all speak MP4 fluently. Why? Because it's compatible with virtually everything. It's compact, and it plays nicely with the most popular codecs, which we'll get to in Part 3. The catch? MP4 is designed for delivery, not editing. Under the hood, it uses something called interframe compression, meaning instead of saving every frame as a complete image, it only saves the changes between frames. That's great for file size. It's brutal for editing software trying to scrub backwards through a timeline. But for finished content going out into the world, MP4 is your default for a reason. It's the box everyone has. Use it. But here's the catch. If MP4 is for delivery, what's for editing? Meet MOV. Apple developed this format for QuickTime back in 1991. And while it's had a long life, it's still the go-to container for professional editing pipelines, especially on Mac. Final Cut Pro loves it. High-end cameras from Canon and Sony shoot in it. And the reason is simple. MOV supports higher quality, less compressed video data, which makes it far more flexible when you're cutting, color grading, or applying effects. Think of MOV as the reinforced heavy-duty crate versus MP4's cardboard box. It holds more delicate cargo. Better. The downside? Size and compatibility. MOV files are larger, and on Windows, they can be finicky without the right software. They're not built for the internet. They're built for the edit suite. So, shoot or export in MOV when quality in post-production is the priority. Deliver an MP4 when you want it to play everywhere. Now let's take a quick detour to the past, because understanding what didn't work tells you a lot about why everything else exists. AVI, Audio Video Interleave, was introduced by Microsoft in 1992. For most of the 90s, it was the video format on Windows, and it worked for its time. But here's the problem. AVI has almost no native support for modern compression. It was built in an era before the internet made file size a critical concern, and it shows. AVI files are enormous. A 1-minute AVI clip can be 5 to 10 times larger than the same clip in MP4. It also has limited support for modern audio formats, subtitles, and metadata. By the time broadband arrived and streaming became normal, AVI was already a legacy format looking for an exit. Today, you'll encounter AVI mostly in old archives and legacy workflows. If you're receiving AVI files from clients, transcode them immediately. Don't edit in AVI. Don't deliver in AVI. It's the video equivalent of sending a fax. Why does this matter? because AVI's failure created the demand for something modern, open, and powerful enough to handle everything. Which brings us to the fourth container. If MP4 is the cardboard box and MOV is the reinforced crate, MKV, the Matroska video format, is the industrial storage unit. It holds everything. MKV is an open-source container developed in 2002 by the Matroska Project, and it was designed to be the most flexible video container ever built. One MKV file can hold unlimited video tracks, unlimited audio tracks, multiple subtitle streams in different languages, chapter markers, metadata, attachments, the works. This is why MKV became the standard for high-quality video archiving and home media servers. If you've ever downloaded a film from a private tracker or loaded up a Plex library, you've seen MKV everywhere. The catch? Native browser support is nearly non-existent. You can't embed an MKV on a web page. It's not a delivery format. It's a preservation format. Use it when you want to store everything about a video in one place, with zero quality loss, indefinitely. Here's where things get interesting, because WebM is kind of a cheat. WebM is both a container and a codec ecosystem, developed by Google in 2010 specifically for the web. It was built to be open, free of royalties, and fast to stream in a browser. Unlike MP4, which requires licensing fees for some implementations, WebM is completely open source. Remember the box analogy? WebM is a custom box that was designed to carry specific contents: VP8, VP9, and AV1 codecs. And it was designed specifically so browsers like Chrome and Firefox could play video without paying anyone a licensing fee. It's not going to replace MP4 for general use. But if you're a developer embedding video on a website and you care about load speed and licensing costs, WebM is a serious option. It's the bridge between the container story and the codec story, which is exactly where we're headed next. Now we're inside the box. Welcome to Codecs. H.264, also called AVC, Advanced Video Coding, was finalized in 2003 by the ITU-T and MPEG standards bodies. And it is, without question, the most widely deployed video codec in human history. According to Cisco's Visual Networking Index, at its peak, H.264 was used in over 80% of all internet video traffic. Think of H.264 like the internal combustion engine of video. It's not the newest technology. It's not the most efficient. But every single thing on the road can use it. Every device, every browser, every platform. It just works. H.264 achieves excellent visual quality at relatively small file sizes. A 1080p film encoded in H.264 at a reasonable bitrate looks great and plays smoothly on hardware that's 15 years old. That's the magic of it. If you're exporting anything for broad public consumption and you're unsure which codec to pick, H.264, every time. It's the safe choice, because the safe choice here is genuinely excellent, but nothing lasts forever. H.265, also known as HEVC, high efficiency. Video coding was released in 2013. The headline stat, it delivers the same visual quality as H.264 at half the file size. The researchers at Fraunhofer Heinrich Hertz Institute, one of the key developers, proved this consistently in controlled testing. Half the size. Same quality. Sounds like a straightforward upgrade, right? Here's the catch. H.265 uses patented compression technology, and for years, the licensing situation was a mess. Multiple competing patent pools meant device makers and software companies were reluctant to build full support. Even today, some browsers won't play H.265 natively without a hardware decoder, so we're in a transitional period. H.265 is dominant in 4K streaming. Netflix and Apple TV use it extensively. iPhone cameras shoot in HEVC by default. But for universal web distribution, you often need to offer an H.264 fallback. It's the better engine, but not every road supports it yet, which is exactly why a new player entered the scene. A V1 is the codec that's trying to end the format wars. Released in 2018 by the Alliance for Open Media, a coalition that includes Google, Apple, Microsoft, Netflix, Amazon, and Mozilla. A V1 was built to be two things: better than H.265, and completely royalty-free. The numbers back it up. Studies from Netflix's own engineering team showed AV1 achieving roughly 20% better compression than H.265 at the same quality level, meaning smaller files, faster streams, lower bandwidth costs. For a company streaming to hundreds of millions of people, 20% is enormous. The obstacle is processing power. Encoding an AV1 is still computationally expensive. It can take significantly longer than H.264 to encode, but hardware support is catching up fast. YouTube streams in AV1 by default where supported. Twitch uses it. Modern GPUs from NVIDIA, AMD, and Apple Silicon all include dedicated AV1 hardware encoders now. A V1 is not quite the universal default yet, but the trajectory is clear. Remember the twist I teased at the start? Here it is. The format you choose matters way less than understanding why formats exist. Every single thing we just covered, MP4, MOV, AVI, MKV, WebM, H.264, H.265, AV1. Every one of them exists to solve a specific problem: compatibility, file size, quality, licensing, archiving, streaming. Once you see formats as solutions to problems rather than a random list of confusing file extensions, the right choice becomes obvious every time. Delivering to the web broadly, MP4 with H.264. Zero surprises. Editing a high-quality project? MOV container, consider H.265 if your system supports it. Archiving forever? MKV? Put everything in there. Building for the future of the web? WebM with AV1. Got an old AVI? Transcode it. Immediately. That's it. That's the whole thing. You now understand something most people who work in video professionally couldn't fully explain 10 minutes ago. If this finally made video formats click for you, hit the like button. It genuinely helps this channel reach people who are drowning in export settings right now. Subscribe if you want more of this kind of thing. We break down the technical side of video, audio, and production without making it feel like homework. And drop a comment answering this. What's the one export setting that's confused you the longest?